Hello! Welcome to today's lesson on the properties of permanent and induced magnets. Today we'll discuss the characteristics of permanent magnets, including their persistent north and south poles and how they interact with each other. Next, we'll find out what an induced magnet is, using practical examples to show how common objects like paperclips can become induced magnets. Finally, we'll compare how permanent magnets and induced magnets depend differently on external magnetic fields. So far, you have learned about the fundamental characteristics of magnets, including their magnetic fields and poles. Building on this foundation, we can now delve deeper into understanding the different types of magnets. This lesson will advance our comprehension of magnetism, enhancing our broader understanding of magnetic phenomena and their applications in physics. Let's get started.
So, what are permanent magnets?
A permanent magnet is a material that consistently produces its own magnetic field without the need for an external source. Permanent magnets always exhibit a north and south pole. This means one end of the magnet is always a north pole, while the opposite end is always a south pole. Bar magnets and fridge magnets are common examples of permanent magnets you may have encountered. When you bring two permanent magnets together, they can either attract or repel each other. If you align the north pole of one magnet with the south pole of another, they will attract. Conversely, if you align the same poles, north-north or south-south, they will repel. This attraction and repulsion can be used to test whether a magnet is a permanent one. If two magnets can both attract and repel each other, then both are likely permanent magnets.
So what are induced magnets?
An induced magnet is a material that becomes magnetized only when placed in an external magnetic field. Unlike permanent magnets, induced magnets lose their magnetism when the external magnetic field is removed. For instance, take a regular paperclip. Normally, it doesn't exhibit any magnetic properties. However, if you place it near a strong magnet, the paperclip will temporarily become a magnet itself, capable of picking up small metal objects. Once you remove the paperclip from the magnetic field, it loses its magnetism and behaves like a regular piece of metal again. The key characteristic of induced magnets is that they are temporarily magnetized by the presence of a magnetic field. When magnetism is induced in a material, one end becomes a north pole and the other end a south pole. The orientation of the poles ensures that the induced magnet will always be attracted to a permanent magnet, regardless of the pole's alignment. For example, if you place the south pole of a magnet near the left side of a nail, a north pole will be induced on the left side of the nail to ensure attraction. To summarize, let's compare permanent and induced magnets in terms of their properties. Permanent magnets generate their own magnetic field and do not depend on an external source. Induced magnets require the presence of an external magnetic field to become magnetized. Permanent magnets retain their magnetism even when removed from a magnetic field. They remain magnetized permanently. Induced magnets lose their magnetism quickly once the external magnetic field is removed. In terms of interaction with other magnets, permanent magnets can both attract and repel other magnets, depending on the orientation of their poles. Comparatively, induced magnets are always attracted to other magnets, regardless of the pole's orientation. They cannot repel another magnet. These distinctions are crucial in understanding how different types of magnets function and interact in various scenarios and applications. In today's lesson, we explored the properties of permanent and induced magnets. We learned that permanent magnets generate their own consistent magnetic field and retain their magnetism indefinitely, displaying distinct north and south poles that can attract or repel other magnets. On the other hand, we discovered that induced magnets only become magnetized in the presence of an external magnetic field and lose their magnetism once the external field is removed. Induced magnets always align their poles to ensure attraction with a permanent magnet, but cannot repel other magnets. This understanding is fundamental for further study in the field of magnetism and its practical applications. Watch the rest of the GCSE physics course at Sophos Education.